Okay, cool kids. So now what we're going to talk about today is absolute value. So when you have absolute value problems, one thing I want you to kind of, refresh your memory first on what is absolute value. So absolute value is when you have something inside these absolute value bars. So it could be a 2. So absolute value of 2 is 2. It could be -2. Absolute value of -2 is also 2. So a couple of things to know is when you're working with absolute value, essentially you're going to do, let me back up. If you had X, right, this could either be positive X or negative X. We don't really know. Just like if we had this and the X was in here, we didn't really know if it was positive or negative. So what we're going to have to do when we solve these kinds of problems is we're going to set up problems and we're going to do them essentially twice, which I know students are going to be grumpy about because you don't like doing double math, but that's what we're going to do. Okay, so let me write out a problem that's just a little bit more of a simple problem, just so that you get the idea. So the absolute value of x plus 1 equals 7. Okay, so let's go ahead and set this up in two different ways, because either this is positive, right? Either x plus 1 is actually 7, or x plus 1 is actually -7, and the absolute value bars are what converted it to be the positive. So we're going to go ahead and subtract 1 from both sides. We have x equals 6. And over here, if we subtract 1 from both sides, we have x equals -8. We don't really know which one is right. Are they both right? Is one of them right? Is neither of them right? And so we're going to test. Okay, so let's go ahead and plug this 6 back in. 6 plus 1 equals 7. Check, we agree. So that means 7 is one of our solutions. Here, we're going to do the same thing. -8 plus 1 equals -7. Yeah, that one checks out. So if we were to write our solutions on the number line, we have -8 as a possible solution. I don't know how many dots there are. And then we have 6 as a possible solution. And so we would do a closed circle right here because it is either -8 or it is +6. We could also write this in set notation. So we could write x such that x equals -8, comma, x equals +6. You could write an or here. It's really up to you. Okay, so that's how we do it with the basics. Let's go ahead and do this with a more complex problem. So what we're going to do first is we're going to first solve for whatever's in the absolute value bars. So let me show you what I mean by that is if you had a complex problem, okay, so this is pretty complex. We have something in the absolute value bars over here. We need to get this all by itself. So that's what we're going to do first. So we're going to add 9 to both sides. We now have 2 times 5x plus 1 equals 4x. 17 plus 9 is 26. And now we're going to divide by 2 on both sides because, again, we're just trying to get this by itself. So we have absolute value of 5x plus 1. It's the only thing on this side of the equal sign, which was our goal. We just have to finish this. So 4x divided by 2 is 2x. 26 divided by 2 is 13. That's an ugly 13. Anyway, so once you do that, this is when we're going to start working with what I said, setting up 2 problems to solve. So the first one that we're going to solve is that 5x plus 1 equals 2x plus 13. Okay, this is problem number 1. Our second one, and I'm going to erase this, but you can come back to it if you need it later. Just rewind. Is that we have to take the negative case. What if that 5x plus 1 is actually negative, but the absolute value bars are turning it positive? So what we're going to do is we're going to put that negative sign. We're going to do 2x plus 13. Okay. Now, I actually don't care which one you solve first. I'm usually a left to right reader, so I can start over here. But earlier I said this one was first, so I don't know. Now I don't know which one to do. Just pick one. It doesn't matter. So we're going to subtract 1 from both sides. We have 5x equals 2x plus 12. We're going to subtract 2x from both sides. So now we have 3x equals 12 and divide by 3. So x equals 4. Maybe. We'll check it. Okay. Now on this side, I always like to start with distributing that negative. So we have negative 2x minus 13. And we have our 5x plus 1. So I'm going to start by subtracting the 1 again. I think that was a useful first step. So I have 5x equals negative 2x. Negative 13 minus 1 is negative 14. I'm going to add 2x to both sides. So I have 7x equals negative 14. Divide by 7 on both sides, or x equals negative 2. All right, so those are our two possibilities. It's either x equals negative 2, or it's x equals 4, or maybe it's neither of them, and we're going to check. I'm going to use my red pen to check. So I'm going to plug this negative 2 in. So 5 times negative 2 plus 1 equals negative. Do I want to do it this way, or do I maybe want to do it from the original equation? I think I kind of want to do it from the original equation. I'm actually just going to do that. Okay, so this was the original equation. It looked like this. I'm going to go ahead and plug in my x here. Okay, so let's check this. So 5 times negative 2 is negative 10, plus 1 is, this is negative 9. So absolute value bars make that positive. So 2 times 9 minus 9. So this is 18 minus 9. Okay, so over here we've got a 9. This is 4 times negative 2. This is negative 8 plus 17. This is also 9. Okay, so that one works. Over here, let's check it. So again, that original equation has the 2, 5, 4 plus 1 minus 9 equals 4, negative 9. Oops, I wrote negative 9, but I meant to write 4. Right? Yeah. Because it was originally 4x plus 17. So this is 4 times 4 plus 17. Okay, so 5 times 4 is 20, plus 1 is 21. That doesn't change because of the absolute value. It's just still positive. So 2 times 21 is 42, minus 9 equals 4 times 4 is 16 plus 17. So over here, I have 33. I didn't really finish this one, but this is also 33. So 33 equals 33, check. So if I was to graph this, my solution would look like this. So I would have the negative 2, negative 1, 0, 1, 2, 3, 4. Okay, and my solution I'll highlight is there's a dot here, and there's a dot here. Now, I could also write this again in that set notation. I could say x such that x equals negative 2 or x equals 4. Okay, so let's move on to another example of these. If you need to come back and check this or try it again or make me go slower, feel free to do that. Pause at any time. And yeah, if you get stuck on anything, ask me questions. Let me get this erased and I'll put another example up here. Alrighty, there we go. So let's go ahead and do one more and then I'll stop and let's take a break. So 2 times x plus 1 minus x equals 3x minus 4. Okay, So what we need to do again is we're getting this absolute value being all by itself. So I'm going to go ahead and add x to both sides. 3x plus x is 4x. And now I'm going to divide by 2. So I have x plus 1 equals 4x divided by 2 is 2x. Negative 4 divided by 2 is negative 2. So this is what I'm going to put into my two equations. I'm going to have the x plus 1 equaling 2x minus 2. And my secondary equation, I'm going to erase this. Actually, I do kind of want to keep that top part. So I'm going to just put it underneath. So right over here, I would also have my second equation, and that's going to be the negative version of this. Okay, so now I have both of these equations, this one, and I'm going to work on solving them both. So I'm going to subtract 1 from both sides. I'm going to subtract 2x from both sides. So I have negative x equals negative 3, and that can be divided by negative 1. All right, over here, I'm going to distribute that negative. So I have negative 2x plus 2 equals x plus 1. Let's go ahead and add 2x to both sides. So I have 3x. You can also go ahead and subtract the 1, make that a simpler step. 2 minus 1 is 1. And divide by 3. So I have this as x equals 1/3. Okay, so now I'm going to go ahead and plug that in to check. Okay, so that's kind of the tricky part too. Let's do 3 plus 1 minus 3 equals 3 times 3 minus 4. So this 3 plus 1 is 4. 2 times 4 is 8 minus 3. So this is 5 equals 3 times 3 is 9. So 9 minus 4 is also 5. So check. That one's good. Let's check this one over here. So 2 times 1/3 plus 1 minus 1/3 equals 3 times 1/3 minus 4. So 3 times 1/3, that's the easy one. We'll just do this 1 minus 4. This is negative 3 on this side. Okay, let's do some fraction work. So 1/3 plus 1, I'll make that 4/3. 4/3. So then this is 2 times that, that's 8/3. And 8/3 minus 1/3 is 7/3. 7/3 does not equal negative 3. No. So that's actually false, and that's not one of our solutions. So our only solution is x such that x equals 3. That's the only one that actually works for this problem. So you always have to check, because sometimes you're going to have what we call an extraneous solution, and it's basically there to fool you, which I really hate because I don't like math to fool you. So just double check. If it's false, believe it's false, and just take the one that's true.